Okay, I think we're ready. I'm going to go ahead and start. So I'm very pleased to be here. I'm Ed Seidel, the director of NCSA, and I'm a professor in physics and astronomy. And I've only been here for a couple of months as the director, but it was clear to me from the very beginning that this is one of the activities that we have going on within NCSA that I think is a model for many others that we hope to develop. And it's very important, and I've known Wen now for, I don't know, a good part of a decade at various meetings and so on where we've gotten together. I was at the National Science Foundation for a while, and although I don't work in this area, I'm a physicist. It was clear to me across all areas of NSF, not only were big data the growing concern, the one thing that actually united every single unit within NSF, but also the GIS community was popping up everywhere in small projects, across many of the directorates, in big projects like over $500 million projects like the NEON project or the Ocean Observing Network and so on, the OOI project. And so I became more and more aware of how important this area is. Recently, I had a chance to meet with Boodoo and was down in Oak Ridge, and I've been watching what's going on here. So it's clearly an area that's whose time has come, that's expanding a lot. So anyway, I just wanted to say that from the point of view of the NCSA director, where you might think that it's about supercomputing, it's largely about applications of growing areas of scientific computing and big data that we're really interested in supporting, of course, supercomputing being one of those. So let me, with that just sort of introduction, get into the actual panel discussion here, which is on the impact of CyberGIS and the center here on research and education at the University of Illinois in particular. And so we have a group of panelists, and I'll have you introduce yourselves maybe just very briefly so you can all have a minute to say hello. And then we'll get into, as I understand it, you have something like 5 minutes of things you've prepared to talk about, or you are prepared to talk about, even with if you're not actually formally prepared, but I'm sure you can all talk about a number of questions, and then I have some questions here to make sure we stay on track. I'll try to keep us to these points. So let's just start with John Towns over there.
Oh, we're going to go backwards.
We're going to go backwards, just to keep you on your toes.
I'm used to being on papers and stuff where it's alphabetical, and I'm always at the end.
Well, you're first today, John.
So my name is John Towns. I run the Collaborative eScience Programs Office here at NCSA. And I think I'm sort of playing a little bit of Ed here since he's chairing, so I'm playing a little bit of his role here too. And so our interest here is perhaps a little bit different than several of the other panelists, in that the NCSA is trying to facilitate cross-disciplinary research activities and bring as many of them as possible as representatives within the center itself. And so having the CyberGIS Center within the center actually facilitates when we're pursuing these other opportunities that exist. So in fact, let's see, earlier this week or last week, I sat with Wen on 2 proposal opportunities that we're pursuing to see how we can link in the GIS community with other communities as we start to build out. In my case, I largely do infrastructure type projects. So as part of my other roles, I run the PI and project director for Exceed, which is to first order bringing together all the high performance computing and advanced computing major centers that NSF funds, but a bunch of other things too. It's a much more complicated thing than that. But I tended to be involved in a lot of these projects that develop infrastructure in support of research. And a great interest that I have and the center has is how do we facilitate the interdisciplinary research that really is beginning to emerge as being very important. I think many of you know that. And as Ed mentioned, GIS sort of is popping up in lots of different areas. But I don't know that the bridges between those communities are as strong as they might be. Certainly, probably not as strong as they might be, but we would want them to be stronger. So having the CyberGIS Center as being officed here in this building puts those staff in regular contact with folks from a lot of different areas where they may not run across them otherwise, and really does help to facilitate building up those faculty relationships between disciplines, and then how the NCSA staff can get involved in that too. So I'm very excited about the establishment of this center and of the potential opportunities that we have going forward for pursuing a lot broader scope of things. So I think we're just staying to a couple of minutes.
We're just doing the introductions now, so shorter introductions.
I was answering the questions already. So.
All right, go ahead.
So I'll do a quick introduction.
And not answer the question.
I'll try not to. My name is Luis Rodríguez. I'm an associate professor in agricultural and biological engineering. My expertise is in systems engineering, systems analysis, and I've spent most of my time studying various problems in food and agriculture. So maybe that's short enough.
Good.
That was what I was supposed
Yeah.
to do.
Good afternoon. My name is Gary Miller. I'm the Associate Executive Director for the Prairie Research Institute. My background is water treatment, water quality management, industrial process improvement to make them more green and sustainable, and I've helped develop national information network system. So I guess I'll leave it at that.
I'm Ximing Kai, a professor in civil and environmental engineering. My research is on hydrology and water resource planning and management, use systems techniques, including GIS. Thanks.
Hello, everybody. I'm Jana Diesner. I'm on the faculty in the Information Science School with a joint appointment in computer science. I do research right at the nexus of machine learning, natural language processing, and network analysis.
I'm Wendy Tamcho, and I'm a professor with appointments in political science, statistics, and here at NCSA. And my research is primarily in developing statistical and computational models for social science.
Good. Okay. Well, thanks. So I don't know if this works. Do you all have things you want to just launch into, or should I start going through this list of questions perhaps first? So the first question, just if you haven't seen them, or if you're on a different panel that you think from the one you think you're on, the first question is, what new research frontiers demand CyberGIS advances? So does anyone want to take a stab at that, or do all of you? Go ahead.
Because I'm not sure I can address any other questions.
Okay.
I like to put a few things on the CyberGIS from perspective of a researcher in hydrology and water resources. Hydrology and water resources is one of the most active areas which have been using and also promoting GIS. So starting from 1970s, hydrologists start to shift from lumped conceptual models. What is lumped model? That means like for whole river basin, we just have one unit. It's a lumped model. And we shift from lumped model to distributed models. Of course, that take advantage of computers and also GIS. Because to my knowledge, I think GIS probably started around the same time. So GIS actually has helped hydrologic modeling a lot. So today, most of the popular hydrologic or water resources models have an interface with a GIS package. So with that interface, one can extract the data from the popular database and make a distributed or semi-distributed model run in a few days. That's pretty quick. And we can, without GIS, we might have to do that. We might have to do that by month. But on the other hand, neither hydrologists nor clients are satisfied with hydrologic modeling today. Although we could get a model run in a few days very quickly, but almost everyone may still have some headache about how to calibrate a model. So with lumped models, we calibrate the model to a system level output. That's not difficult, right? We can manipulate the data and make the model output match the system level observation. But to calibrate the model to particular spatial patterns, that's not easy. So the challenge is really with, I think there are three aspect challenges. One is the data incompleteness, incomplete data or the error with the data. And the second one is the structure error with synthetic models. And the third one is the computational difficulty. So those things make calibration of a big model very difficult today. So hydrologists might be really happy to say a platform which could help identify multiple data sources from the so-called big data, and which could also provide a kind of solution environment which would include choosing the right model from many available models. And of course, also can some way resolve the computational, the computing block. So I think regarding those challenges, we would put our hope on CyberGIS because to my understanding, this CyberGIS might be a tool not only support data, but also support modeling. But on the other hand, hydrologists might be sad because if we really have this CyberGIS, the world may not need so many hydrologists as we have today. All right.
Thanks. Anyone else want to pick up on this particular topic?
I have several things, and I was thinking very carefully because I knew Ximing was going to be speaking as well, and we have many parallels in our work.
Okay, that's good.
So, and I chose wisely because I didn't want to spend too much time speaking about water. He's far the expert. Now, that being said, water is an essential component when it comes to food and agriculture. Without it, of course, it is probably the primary nutrient behind photosynthesis and the energy in photosynthesis. So, now, that being said, we find that food and agriculture is challenged in its perceived sustainability to potential consumers out there all the time from a number of different perspectives. Now, in order to try and reconcile these issues, we do struggle then with data, as Ximing pointed out quite rapidly, whether it comes to climate-related information, local information as to wherever you might be producing your product, and these all end up becoming local scale issues. Now, that's always juxtaposed as the way we assess the performance of our food and agricultural systems, which are generally are related to how secure is your population, and depending on which part of the world you're talking about. Some of the sustainability measures like greenhouse gas balances that you might be considering, or even some of the environmental impacts related to, say, hydrology. Is your food and agricultural system associated with some sort of hypoxia, stream, or river eutrophication? So these are major issues. Now, if you want to come back and try to regulate these systems or improve them, policy ends up coming into play. And it is not easy then to reconcile the impact of policy, at least regional, maybe national, to individual farmers locally, and then back to their environmental impacts or social impacts nationally, internationally. So if there's a major opportunity, it's trying to reconcile these issues down for all sorts of decision makers that occur either locally, like farmers, or nationally, internationally, like policymakers. It's not an easy problem. We do juxtapose these in our work on a regular basis, but with new visualization tools, data aggregation tools, computational scale-up tools, we do anticipate greatly expanding the scope of problems that we can solve, analyze, work on through these types of tools. So we're very excited in that particular respect.
I'd like to.
Go ahead, sure.
We agree with all that. In the Prairie Research Institute, we've been collecting environmental natural resource data for over 100 years. So we have it from field notebooks, which were sort of the original databases, all the way up to real-time data that we're collecting today. And we have all these challenges. that I've stated. The question is about a research frontier, and I guess I want to focus on the development of sensor technology to provide us more data and more precise data than we've ever had before. And I think we're right on the beginnings of an explosion of the ability to collect more data and to better understand the world environment that we live in than we've ever had before. When we have done computer modeling in the past, or we created maps in the past, we had pretty big gaps between our data points. Or if we're studying the fish population in the Illinois River, a grab sample here and a grab sample there, or the chemistry of the water, large distances between sample points and time, and different sampling methods. And all of a sudden we're on the verge of being able to deploy sensor networks that can collect readings every 15 seconds all across the profile of a stream and up and down the stream. And that's exciting. I think our computer models aren't, and our even infrastructure is not really equipped to handle that. But all of a sudden we're going to be able to understand the world in ways we never understood it before. And I think that the challenge is not only for us to be able to handle all the data and all our infrastructure and all our models and the way we go about doing our science, but it's to interpret that information of what it means and to the world. And the point was made earlier that a lot of our decision making is sort of not looking holistically at things. But for example, in Illinois, we have more units of government, I've heard, than any other state in the country. And decision making is down at the township level, the drainage district level, and at the very local level we make decisions. And all of a sudden we're going to have data that we will be providing publicly that's going to be showing us that the decision in this district is affecting this district, and this district, and all of a sudden the authority that district had is going to become into more question about, hey, the decision you're making is affecting all of us in a way we never understood before. And so I think that it's exciting. We're on the cusp of, as scientists, have more data than we ever had before, but I'm not sure we know what to do with it. And it's important that we help the public understand what these data mean and help interpret that data. And then I think the political science, social scientist folks need to come into play here, because I think we're going to be really challenged in terms of our systems out there in dealing with the data. So those are some of the challenges I see on the research side.
Good. So I realize I'm not exactly following the rules here because I didn't allow everybody to have 5 minutes, but in a sense, everyone's taking 5 minutes. So why don't we just continue to go through the roster here? Would you all like to make some comments on this particular question or say anything else before we move on?
I would rather go to the next question.
Okay. All right, we'll do that then. Wendy, the same? Okay.
Another question.
Okay, good. So I'm going to just take chairman's prerogative and sort of turn the question around a little bit, because I'd like to hear an answer to this one, which is not so much what research frontiers are demanding CyberGIS, but what does CyberGIS really demand in terms of research advances, and in particular, we had an idea a few years ago at NSF that we never quite carried out, but I'm interested to know if it would be of use. So along the area of heterogeneous data collection from disparate sources, which is very much what you do, if you just sort of categorize it like that, do you think that there are common approaches that you either know of or would like to learn from or to be able to use that would be useful, for example, in materials science or in chemistry or other areas? And so we once almost organized a workshop. There was a process we had called the Data Way at NSF, where I was trying to get different communities to come together and spend like a week, literally 5 days, first of all saying they have nothing in common, and by the end of the period thinking that probably what would emerge would be a number of things are actually in common, and we needed to develop some sort of services, technologies, ways to categorize data, and so on, that would actually benefit many of these. So would you see something like that being useful?
That's a good question.
Okay.
Okay, let me try to answer this way. I consider the CyberGIS work I'm affiliated with here as a general utility component for a lot of disciplines. In fact, I would have a hard time coming up with a discipline where it's not relevant, right? It's like statistics in like last millennium and machine learning now. You have it everywhere and you need it everywhere. And I'm pretty happy, or I'm actually totally excited about it. We have an institutionalization of having this general utility technology way of thinking, data access here that allows people from all over the campus, like this row of people here, to engage with CyberGIS expertise and computing infrastructure that we can use to solve here and now problem in whatever discipline we have. An example for that is work that Xiaowen and I are doing together with a student in common. Hank Humers, he's sitting right there, who is in the informatics program. And he is working with us on developing scalable computational solutions for contextualizing behavioral data, which in my case means relations between people and language flow, or information flow between people in time and in space. And for that, having scalable, high-performance solutions that are rigorous and reliable applied to vague and fuzzy large amounts of social data is a big deal for us. And there are a lot of open, pressing needs and research questions that we can now look at using those sorts of, those ways of computational thinking and problem solving that involves a GIS component.
Okay.
So I'll take off on that a little bit. I'd been thinking about this last question that was up on our paper, which is what are the major challenges of adopting CyberGIS for both research and education? And when I read that question, I thought the major challenges were asking that question at all. I mean, to ask that question at all implies that the value of CyberGIS isn't clear, and that people think, what is it a tool or is it a science? And when I hear that, I think, why are we asking that question? I mean, is there no value? And to me, the value is clear. I think if you build it, they will come, right? If you build these tools, people will come and they will use them. And it reminds me very much of, because I'm getting old now, of a debate I heard a lot when I was a kid about computer science. When that first came about, people said, that's not its own thing. That allows you to do math. It's like it's applied math. It's not its own thing. It's a computer. It just does things for you that you ask it. And now, of course, nobody thinks about computer science not as a discipline or not as just a tool or just an enabler of science. And I think CyberGIS is kind of moving in the same direction. It's appeared and people say it's a tool. It's like it only does things for other people. It does things for a social scientist, or it does things for somebody else. And to me, it's this long debate that we've had about what's not math, what's physics. Physics is applied math. What is computer science? It's applied math. What is CyberGIS? It's applied math. And you have to get over this hump to become, your own, to develop your own importance. And I think the major challenge right now is in redefining disciplines, is in redefining fields. And I think higher education is just getting started in that. I think we're just discovering, for whatever reason, that all great problems are interdisciplinary. That it's really not just social science, chemistry, engineering as their own thing. And to me, this has been clear because I'm very interdisciplinary. I think when I tell people I'm a political scientist, they have in mind that I want to talk about the election. Actually, I don't even vote. I hardly ever follow elections. It's just, okay, that's actually true, but I tell people. But, some days I sit and all I do is I program all day long. I look like a computer scientist. I sit there, I'm trying to think of a new algorithm. I don't look like what people think of as a political scientist. Some days I sit and I'm developing statistical models all day. I look like a statistician. And all day I do these things, but nobody, I sit on the plane, I tell people I'm something other than a political scientist because then they want to talk about the election or war, and I don't know anything about any of those things actually. But I think people don't understand that so many of the world's problems now are completely interdisciplinary, that it's about data and looking at data. the rise of statistics, the rise of computer science. This is the rise of informatics and also of CyberGIS. And I think people aren't making that connection yet. And I think it's pervasive in education. Like my children, actually my oldest is completely homeschooled, so I get to teach them how I want, but my other children go part-time to school, and they're in science, they have this idea of science is this, and then they switch, and it's social science. And in social science, they're not doing any science. They're doing, social science, social studies, and it's a completely different thing. And then when they go do art, it's art. There's no integration of, disciplines. There's no integration of thought. And my oldest son, who's homeschooled, he's a little weird because we're homeschooling, and I know how people look at me when I say we homeschool, but when I teach him stuff, when we're talking about social science, he looks at me and I grab these huge data sets and I show him how I compute things and I show him what I do with stuff, and to him it's all integrated, right? It's all one thing. CyberGIS to him he understands it, right? But the kids in school now, they don't understand it, and even in higher education we don't understand it, because when I tell people I'm a political scientist, I know you're thinking the same thing. That's not what I do. And that is, I think, the problem. That's the major challenge, is that people can't integrate and see how these things fit together. And that's going to be the hindrance to unlocking innovation, is because we don't train people correctly. We don't train them right, and they don't know how to use the tools, and then they don't think certain disciplines use the tools.
Go ahead, quick response, and then we'll move on to some of the questions. That's a good lead into some of the other questions,
Okay,
actually.
sorry, I just a quick follow-up on this interdisciplinary study. I just finished a proposal today. So we have 10 faculty members from different areas, including social scientists and physical scientists. So in our first couple of meetings, it was really difficult for us to come to a common idea, because we all have different mental models, different data, computer models. I'm just thinking about if, actually, Xiaowen is with us. So if CyberGIS some way can help us to, maybe I should put it in this way. No matter how different our mental models, our data are, but everything should have a feature of spatial scale and the temporal scale. So with this CyberGIS, if it could bring people from different areas together by the spatial scale and temporal scale, and then some way that might help us to identify our boundaries for research or for thinking.
Okay, so I think I'll skip over the second question about the research breakthroughs. I'll come back to it because it picks up on the themes that Wendy was getting at there about the specific needs of learning CyberGIS in your research and education programs. And so there were several that you were getting at, for example, how you really do deal with an integrated approach in education and so on, and then perhaps common things that might be important for CyberGIS in particular that are common across other disciplines and so on. But anyway, to the question, it says, what are the specific needs of learning CyberGIS in your research and education program? So who wants to take that one on? Okay.
Sorry.
Go ahead.
I'm just thinking about, so usually we give our students some classic homework problems from textbook, right? The problem statement is given, data is given, and the problem the students are required to solve that. So with more advanced GIS, probably we can give students more opportunity to do exploration. So give them the problem and provide them a tool to search, to explore supporting data and the supporting tools. So probably in the near future classroom, we could have that kind of technology to educate our students in that way.
Good. Okay. Go ahead.
So I've actually been giving this quite a bit of thought, because at our level, thank you, in food and agriculture is so broad. There's a huge amount of different products that we're consuming on a regular basis. So already by itself, food and agriculture can be quite broad, but we want to study those systems. That being said, then you have to bring in a new skill set to deal with large amounts of data, handle the computational aspects of whatever modeling approach you might choose in order to integrate that data. So already then we are adding to this. I see two real key approaches. Of course, if you can find those really eager people that are already available, whether they come from a food and agriculture bent or whether they're coming from a perhaps computer sciences or computational bent, and teach them those other skills. But better yet, I think, the other approach would be to really start teaching people to work in teams, to become interdisciplinary, and not rely on everything that's containable within, I forget what the volume is here, but it doesn't have to be just one brain solving these problems. So I would echo the statement from before. These really good problems are inherently interdisciplinary, and I think one of the key features here right now is that there is a tool here that allows us to be more interdisciplinary. So that being said, finally, to get that integration, probably there needs to be a commonly shared approach to quantifying those outcomes. However you're going to measure the performance of the systems that you're going to be studying in an interdisciplinary fashion, that's where people are going to interface, and probably those are the key features that you're going to end up visualizing down the line, geospatially, temporally, utilizing tools that I think we're going to be seeing here.
So just comment, one of my real interests here as the director of NCSA now is to move it in a direction to help support particularly interdisciplinary research and education, because we have a lot of the expertise in advanced computing, the technologies, the software, high performance, parallelization, visualization, and increasingly in the areas of big data. And so I think we're a great kind of laboratory for interdisciplinary groups to kind of come convene and figure out how to take advantage of this environment. So I'd really like to get recommendations over time. And in fact, I'm working with the provost and the vice chancellor for research to come up with a set of recommendations for how NCSA can better integrate across the campus, particularly to support these kind of things. So I'd love to hear your thoughts. I mean, not necessarily now, but just over time to figure out how we move forward together. Let me, being mindful of time, I'm not sure what time it is here. We have 20 minutes left? Okay. I'd like to move on perhaps to a slightly related question here, how to demonstrate the value of CyberGIS education to others. So some people may think of it as actually rather narrow, even though, as you're all demonstrating, it's extremely broad. And so what are the sort of hooks to get people to understand why this is so important?
Maybe I'll
go ahead,
start
Jana.
with that. Because it solves here and now problems that people out there, and I'm not talking about academics, but like other real people have. So currently, I'll give a little example. Currently, I have a project sponsored by the Ford Foundation where they want to measure the impact of a couple of things they are sponsoring. Social justice documentaries, for example. You release something like that, what's your social return of investment? How far does it go? How broad does it go? And whose mind and behavior does it change over time, starting from here and now? And for that, we are using CyberGIS knowledge and information in order to show that, and in order to make that more measurable and more rigorous. Even though it's a very broad and seemingly fuzzy question, but we actually can measure those things. And having components like that, contextualizing information flow and interaction between relevant stakeholders in space and time is relevant. And people at the Ford Foundation are actually adopting that for measuring the impact of the things they are sponsoring. So that takes it out of our pure research domain and actually does something for somebody who cares about that.
Mm-hmm. Others have good examples?
I think this is in this vein of this question. I was thinking about making maps, and the Geological Survey, U.S. Geological Survey, et cetera, made maps for a long time, and I'm not a geologist, haven't made those kind of maps, but there's a tremendous amount of pride that goes into making those maps. And I remember the peer review, all the field work that's done to gather the data, and then the write-up about documentation of that map and how the map should be used and how it should be interpreted and what are the limitations to that map. And then I remember we'd publish a map, and then people wanted to use that map, and we were very guarded and protected of that map because we were the only ones that understood the map. We were the only ones that understood what data were missing. We felt like we were the only ones that understood proper use and interpretation of that map. And so now we have to, with CyberGIS, it's such a powerful and, I guess you use the word, seductive tool. I mean, it's amazing, but it's dangerous in a sense because, I guess back to the concept of critical thinking, we need to teach people to understand that maybe their first impression of this map isn't necessarily how they should interpret it or use it, and we need to be engaged with the users. And that's my main point, I guess. We can produce maps, we can produce GIS, CyberGIS imagery and technologies and make it available to the world, but somehow we need to be engaged with the users so that we understand how they're using it, how they're interpreting it, and then maybe adjust what we're presenting or help them to properly use it. Somehow that's a real challenge because I think we just put it up there and move on to the next thing. And I think it's really important. So this education, to me, is really understanding proper use, limitations, and interpretation of what we are producing.
So that leads in, I think, naturally to the next question here on the list, which is what are the major challenges of adopting CyberGIS for both research and education? Do people want to comment specifically on that?
So I had commented on that
You did,
already.
right.
But I wanted to add, just kind of building out what you were saying, that I think a lot of the value of NCSA, this is kind of answering your question too, is bringing together the communities. And I think I've been part of NCSA, I don't know, 6 years now. But the big boon to being part of NCSA for me was going to NCSA's sponsored seminars because they were outside my department. Mm-hmm. And I swear I've gotten my best ideas from listening to people talk that had absolutely nothing to do with anything I've ever even thought about. And you just, you hear their idea, it's on a topic that you're not even studying, you look at their tools, you watch what they're doing, and you think, I can do something like that, or I can use that, right? And every time I listen, it's not that I don't like my own department, but every time I hear a seminar in my own department, it's all about tweaking. I took what you did and I changed this little thing. And you're so ingrained the mindset within disciplines that's all we ever do, at least in my discipline, it seems like. People take things and they'll tweak your model or they'll tweak this or they'll tweak that. There are never any big jumps. And I think when I started coming to these NCSA seminars, I started seeing other disciplines, other ideas, other tools, and I got so many ideas. All my best ideas have come from, sitting in on a seminar by someone in geology or somebody in chemistry or somebody in just some completely, different field that you wouldn't think you'd have any interaction or any, thing in common with. And I think that has been huge for me just defining my research agenda and doing better research and other stuff like that.
That's nice to hear. John, go ahead.
So I see the challenge on a slightly different axis because there are tools being developed that are being applied in sorry, I should be, I guess we're being broadcast too. What I want to see is how do you abstract those things, because for two reasons. One is they are great tools, but they're still hard to use. How do you interpret them? How do you understand what they really are? They are applicable to other areas. So to me, the challenge is how do you abstract them a bit more so you don't have some of these difficulties. You can present things in a more effective way that can be interpreted appropriately by the end user, and you can apply it to other fields, right? So those are a lot of big asks in there. But I think that's another one of the nice features of being in a space like NCSA is because you do have these other disciplinary areas that can say, that does look interesting to me. How do we apply that over here? How do we extend that tool? And in that process, can we make it more useful for all of those that are using it? So it's a different aspect of the challenges. Those are hard things to do, but I'm hoping that we can actually move some of those things in that direction.
I'll probably add a little bit to that.
Go ahead.
Okay. Look, I completely agree with both of those things, and I think there are two components to that. One is the largest common denominator of computational skills that we need north of Green Street and south of Green Street across all fields in order to solve the problems and open questions we have in our disciplines. And that involves a lot of things that are important for CyberGIS as well. High performance computing, correct data representation, data structures, data curation, things like that. And then in addition to that, there is the content domain specialization, whatever it is, geographic knowledge, very, very important. And I strongly do believe that in order to solve the problems we have, whatever your discipline is, you need both of those things. You need strong, solid computational thinking, strong, solid computational skills to some level, and really understand your problem domain. And I think how NCSA is really helpful in that regard is bringing together people from different planes who really have deep subject matter understanding, plus the computational background in order to make those things solvable on a scalable framework.
Mm-hmm. Good. Thanks. So I want to make sure we reserve time for audience questions and interaction with the panel. One question that wasn't asked, in case someone wants to ask it, would be, how does CyberGIS enable new research breakthroughs that might not be possible without it? So maybe there's some examples of that. But let me go first to some audience questions.
So my university was recently approached by a law firm which proposed a class action suit against us for not making all our online learning experiences and objects accessible to the orally impaired, to the deaf. And we expect that following that will be a class action suit from the visually impaired. And for the life of me, I've been thinking about, because I also have some administrative role in this, how do we deal with GIS, CyberGIS, which is inherently on the web, public GIS, how do we deal with that for the visually impaired? Has this crossed your mind at all? Have you thought about this? And do you have any comments?
Really interesting question.
Sorry.
I guess that's the answer.
That's a really thoughtful question. No thoughts, no answers? Yeah, audience answers or other questions?
Actually, there was a discussion of that topic recently on the higher ed listserv, and the response was that not all people are visually impaired to the same extent, and that you can address a large portion of the visually impaired by using certain color combinations to help show what you want to show.
Thank you.
Xiaowen?
Interesting.
So this is a critical problem and question. I think it's wonderful, Peter, you brought it up. Ian Brooks is a leading project for mapping global malaria distribution. We contributed to CDC. I think one of the things in our implementation was this accessibility, because the potential users is anywhere in the world, and there could be anybody has all kinds of abilities. So in the design of user interface, we took very seriously as to this accessibility and make it as simple as possible. Now, this will be increasingly challenging because in the vision of CyberGIS, we're going to, on the broader access space, lower the entry doors for CyberGIS analytics to be accessible to millions of potential CyberGIS users. Well, this is much more difficult than just making the interface to some, simple maps, or as simple as possible we dealt with in the malaria mapping case. So I think it's still very much in the research space, although we did not consider this in the education learning context. But my answer pretty much is a no answer is we have a whole lot of work to do in that space.
Right.
Although in the online mapping space, popularized by Google, Bing, and others, and the online mapping applications, I think these have been addressed to a good degree, reasonable degree. People taking these kind of online maps to learn things now are increasingly enabled. But for analytics, which I think is a big part of CyberGIS, to be accessible in the learning research context, I think that's a fascinating research context.
Budo?
I don't really have an answer for you, but just a recommendation. The International Cartographic Association has a commission to deal with specifically this problem, cartography and geographic information for the visually impaired. So it might be worth looking at their website to see what they've done.
Mm-hmm.
I'll take my turn.
Okay. Quite a thought-provoking question. I mean, a generalization of the question is, how do you make scientific visualization available for the visually impaired? It's right.
So I had to deal with this issue because we had this very important person in the Department of Energy dealing with the electric grid, and everything that we produced was not being acceptable. And about 6 weeks into this exercise, we realized he was colorblind. But amazingly, we found that there people have actually done research to understand what are the optimal colors for colorblind people on a map. I would add to Xiaowen's comments that I think 3D printing is going to change a lot of ways we have interacted with data. We kind of think it's going to make things, but 3D printing is actually going to have a big impact on the spatial data domain applications. But I had a separate question for the panel, since none of you are from our sort of domain. So if you have an application from a postdoc who claims to be trained in CyberGIS, what are the top 3 skills do you think that person has?
Programming.
Knowledge domain understanding, like deep understanding of the problem they're actually looking at, together with that.
So I do list 3.
Oh.
Data and data and informatics. So data aggregation, informatics, processing of that information, modeling. Now that's a wide array of different things, but you have to process the information in order to produce a result, and then eventually you have to disseminate that piece of information in some way that it's digestible by the audience. CyberGIS, of course, the visualization piece becomes very forefront, and that's added with CyberGIS, although there's, of course, other ways to visualize information. But those are the 3 keys that I think those people need to be very strong in. Sorry, Shao. Ximing.
Okay, other questions? We have about a little less than 10 minutes.
So when I was a graduate student, we have this trouble allocate the computing resources, right? So we have a Beowulf cluster, then one student use, some other student cannot use. So I'm wondering, does CyberGIS also have this kind of issue? How do you allocate the computing resources among different researchers? How do you prioritize if there's a issue to allocate all these resources to different disciplines?
John?
I think I have that question. I'm not sure I fully parsed the question. So
why don't you repeat your version of it?
So what I thought I heard is, if you have competing needs for these resources, how do you balance across those disciplinary demands? It's funny you should ask, okay? So I just had a phone call yesterday with somebody leading a team that was doing an external review of our allocations process for Exceed. And this was precisely a point that was brought up, because when we review these allocations that come in, we have an interdisciplinary review panel, but ultimately there's not enough resources. and we have requests coming from a wide variety of domains. And by design at this point, we don't look at the balance across them. And the question is, why don't you, right? And should some domains, for particular reasons, be afforded more of the resources than others? Now, that's a very tricky decision to be made. And it's one that the recommendation that will be in this report is that NSF should be working with Exceed so that, because ultimately we allocate these resources on behalf of NSF. And they have to dictate what that balance of investment really is, what it turns out to be, an investment of those resources across the domains is. So I don't have an answer for you. And when we come to this discussion with NSF, I'm going to bet they don't have an answer for me when I ask that question, because they're going to say, well, we don't know exactly how we're going to do that. So it's an open problem as far as I'm concerned. Now, to some degree, NSF does push some of those decisions by funding resources that are dedicated to particular disciplinary areas. And so, there's some investments in those ways. But for the more generally available resources, there is no, we have no guidance on how to balance across the disciplines when we allocate the resources when there's not enough, and there's never enough. So I guess I don't have a good answer for you. I would like to touch on one other thing, though, and that is particularly in the area of CyberGIS, but also in other areas, what's happening when you look at the national resources is they have a long history of supporting simulation and modeling. And that's a particular usage modality. Whereas CyberGIS is a much different sort of thing when you actually are processing and analyzing data. You have much more complex workflows involved. You have a much more diverse set of resources you need access to. And so to come back to why I think the center is important, the CyberGIS Center is important in conjunction with NCSA, is that we can bring a lot of experience on these more traditional uses of these sorts of resources. But the center brings a new modality of using them that is actually applicable to a broader set of communities. But together we can help learn how to develop the integrated systems that really can support this broader range of science more effectively. Now, that makes the allocation problem more difficult because, again, the traditional way of looking at the allocation is you have this big chunk of iron, right, a big system that you're going to allocate some time to a particular project. And now you don't have this big chunk of iron. You have a heterogeneous set of resources, and any particular scientific workflow, if we use that term, has a different set of requirements against those resources. So we're going to run into some much more complicated issues when it comes to allocating these types of resources as they begin to become more complex in and of themselves to support these sorts of endeavors. So I guess I just gave you back a harder problem. I'm not sure.
So we have about 3 minutes left. Does anybody have a burning question or words of wisdom, or would the panelists like to have the last word? I mean, I don't see people rushing to the microphones, but panelists? Go ahead.
I think, we've outlined a lot of challenges and opportunities, and it's exciting. Last Friday, there was a presentation with the CyberGIS Center on something called the Great Lakes to Gulf Project. And I was excited about that effort because it's a specific application, and they're really working through how to overcome the challenges of integrating the data and presenting the data, and in a collaborative, multidisciplinary fashion. And I think that's what we need to do moving forward. We know the challenges. We can't solve them all in the short term, but we need to work together, identify some specific projects, and build the infrastructure and the understanding and the relationships. I think the CyberGIS Center is just what we need for that.
I don't know if anybody could top that. That's a perfect response, but go ahead.
Anyway, my feeling is it looks like this information technology or computer science, or simply speaking, I can use the CyberGIS, might affect our the way to do research or the way to teach students.
Good.
I mean, I expect that could be more effective.
Any other last comments? Okay. Well, thanks everybody. Thanks a lot.